Hi guys, this is Ryan here from Blockchain Markets, and today I'm with Ivan, founder and CEO of Hypernet. Hi, Ivan.
How you doing, Ryan?
Fine, fine, and yourself?
It's a glorious sunny day here in California.
Really? Nice, nice. Yeah, I mean, in Amsterdam, and I think this day has been the warmest day in the whole year, almost like 30 degrees.
That's incredible.
Yeah, for Amsterdam, it's I don't know where to be. Just like maybe just jump in the fridge or something. Well, as I said, thank you, Ivan, for taking the time to go through the Hypernet, because I got a lot of questions from the blockchain markets community of people that were looking for projects to discuss, and I thought the best thing to do is to discuss it directly with the founder. So thank you for taking the time.
Hey, thank you. I'm happy to talk more about Hypernet with everybody. So this should be good. Should be a good one.
Cool, cool. So just to start, if you can give a brief background about you and probably your team of or your co-founders, and then we just jump into the technology itself.
Yeah, so a bit about me. I grew up in Los Angeles, but my father's from New Zealand, so I ended up down in New Zealand for high school and my undergraduate studies. During that time, I was a chemical engineer and a materials scientist. I floated around to a few different startups down there, from converting carbon monoxide gas to ethanol. I was involved with some ceramic body armor projects, and I also came up with some new process to produce titanium. We can get to that another day. But then I wanted to pursue my love for space travel. I learned everything that I feel like I needed to know out of those other industries. So I came out here back to the States at Stanford, where I met both Todd and Daniel, my two co-founders. My work was all in high energy plasma physics and gravity, extended theories of gravity for space travel. It was quite a shift, but it was a very exciting time to learn more about the physical world, and also to be exposed here in Silicon Valley to the large amounts of just innovation and entrepreneurialism that exists out here in the Valley. While at Stanford, I met Todd, who was in the aerospace department with me for both our masters and PhDs. Also, I left my PhD to start Hypernet, just to throw that out there. I almost completed it, but it was calling me now, and the time's right. So you gotta do things while all the stars align, really. And so I met Todd at Stanford. Todd's whole background is in numerical methods for computational fluid dynamics, structural mechanics, electromagnetics, and so Todd's whole thing is doing very large-scale simulations and numerical methods around that. And what he was most interested in was how can he do bigger and bigger simulations, and the same problems he's running into for those large simulations are the same issues that actually befall us when we start talking about Hypernet itself and what we're solving in terms of distributed computing. So I won't get into that just yet. The third co-founder, Daniel, he was also at Stanford. We met back in 2013. With Daniel, he was quite involved with the blockchain world since about 2012. I don't know if you might have seen a Forbes article on the Stanford Bitcoin mafia. Daniel was one of those guys that was part of that group at Stanford that all left their undergrads to go start a lot of companies in various fields. So Daniel left Stanford to start a solar power electronics company that was acquired by SunPower, where he stayed there to learn exactly like how a large organization operates. And so perhaps the next thing he can take from a startup all the way through to something quite substantial. So really, we've been discussing computing since about for a few years now. This is in various contexts, because both with Todd's research and what some of my colleagues were doing, they were doing quite large numerical simulations, and they would need to dial up large amounts of computing power at government labs around the States or in cloud facilities. And what you end up having is like you you start fighting people for resources, especially when you're starting to talk about, I need to run a simulation on 50,000, 100,000, perhaps if you were crazy enough, even 1 million CPU cores. And so when you start trying to launch large jobs like that, we run into some bottlenecks in the availability, and it may take days, weeks, or months for you to schedule your job. And that was quite a bottleneck for us in the academic community. But as we kind of thought about the problem even more, we were looking around Stanford's campus, and we realized that, well, everyone here has a brand new MacBook Pro and smartphones in their pockets, and that's quite a lot of computing power that exists there if we could just tap into that. And of course, that's not a new idea. It's been around for decades. SETI at Home was one of the first public resource computing projects, where they were looking for weird signals from radio telescope data. And so within this whole framework, though, one of the biggest bottlenecks in distributed computing is, even if you could get all the computers of the world connected together, how do you actually coordinate them to do a very complicated compute task? And what really ends up happening when you look at what people did with SETI at Home, gene folding at Home, IBM's World Compute Grid, the types of problems they were solving were while they were important, were still limited in like scope in the problem class you're looking at. The kind of things they were solving, which were known as embarrassingly parallel. What that means is you take your compute job, you split it up into 600 pieces, and send each one of those pieces out to a computer. Those computers then crunch those numbers locally on their own device, and then they send back the answer to whoever launched the job, and you either put it together like a puzzle, or you're just looking for some kind of, hey, this is interesting. But the moment you want to try to do things that are more complicated, that require intercommunication between the computers, your computational fluid dynamics, financial modeling, training your AI and machine learning algorithms across large data sets, you run into a problem that is solved very well in the cloud to a point. But the moment you move down to this world of distributed computers is, how do you actually sit in the middle, conduct all the processes together, and get them all to do a coordinated compute task? That is the most difficult challenge, and that's what we realized quite early on. But I can pause here if you have any questions, and I can dive into exactly what we're doing with Hypernet.
Yeah, I think it's a good segue to start diving deeper on what Hypernet is.
Yeah, so what we figured out quite soon after we embarked on this journey was, there's all these computers out there. Why can't we create basically a giant world data center, if you will, where every individual that has these computers that are used to for society, you want to check your Facebook or you want to do your work during the day, at night these assets are not fully utilized. During the day too, like, my computer's sitting here right now, I'm not doing too much. And so perhaps we can tap into this vast resource that's there. If you kind of look at the amount of, like, just to kind of put in perspective, when you look at the amount of laptops that are sold globally, like let's say last year, and let's say you price them all at the same price that Amazon charges for their cloud instance of a similar type, it represents close to $150 billion worth of compute power that was just generated in 1 year that was sold to the public. And that's not counting also all the smartphones that are out there. It's not counting the enterprise buildings that are full of desktops. So we start to look at the scope and the capacity globally of compute power. It's quite drastic. And so we wanted to create a platform that could tap into that. The final solution that we've landed on was, well, like, rent out your computers the same way, for Airbnb, you rent out your rooms, or, with Lyft or Uber, you use your car, these resources you already own, and get some extra income from them. So when we start looking at this compute environment, we say, okay, we need to have a marketplace where people can sign in and sell their latent compute power. But also, once you have all those computers and you've been able to schedule your job, how do you then utilize them for the network? And so that's what Hypernet is. It's these two pieces. It's the marketplace and blockchain-based resource scheduler. So if I'm, say I'm Boeing and I want 100 computers for 100 hours to do one of my compute tasks, I type in there, I want minimum of 8 gigs of RAM, quad core CPU, like 3 gigahertz processors, this kind of network latency and bandwidth, find it for me. The blockchain scheduler says, okay, I will find those people that are signed into the network that are going to meet your specifications. It matches you with those sellers. They then fetch the job from Boeing, and then they move off the chain to do the compute. And so once you've moved off the chain, like now you have all those computers that may be across an uncertain network. These computers may die. How do you actually do a parallel compute task now that you have them? And so what we've created is an engine underneath that is if you're familiar with parallel programming models like MapReduce or MPI, this sits there among those, where now we have a completely decentralized parallel programming model that runs as the engine underneath Hypernet itself. So just to recap, there's 2 pieces: the blockchain resource scheduler, and then the underlying compute engine itself.
Very interesting. And sorry to interrupt you, Ivan, but I think now it's a good moment also because you touched upon the parallel computing, which I think it's a very interesting topic that we can discuss briefly, because maybe a lot of people that are seeing this video are mainly I'm not that technical. I don't understand what parallel computing. So maybe if you can explain that a little bit deeper, and then we go back to what you were saying.
Yeah, so this is I'll see if I can pick a good one here. So imagine you have the task I want to run on these computers. But when we talk about parallel computing in the context of Hypernet, these are quite large scale compute jobs, compute intensive things. So in this case, imagine we have a gigantic data set. Let's say there are a bunch of images, and all those images can't fit on a single machine. You then want to be able to, across this distributed data, maybe glean some analytics from it. In this case, maybe you want to do a feature extraction from all those images. Traditionally, what you would need to do is you would need to suck up all those images to a centralized repository. Then you can run all of your image recognition on top of that and get an answer. But what we're saying with Hypernet is, well, for parallel computing here, we leave all those images out there scattered amongst all those devices. You run Hypernet in the background, never need to move the data. Hypernet underneath it does the coordination and lets you learn from that entire data set without ever needing to see the raw data from each individual to do so. Does that answer a question, or should I pick another one?
Yeah, no, it does. I was just thinking, how would it work, for example, in the case of a company like I'm just thinking in a use case. So then, for example, a company like Facebook, and then,
Okay.
if they would like to comply with the new privacy, I'm thinking Europe and the new privacy policies. In this case, it doesn't mean that the private data or the data would remain in the person's device.
Yes. So this is actually one of our main visions here, and it's up to both us and also other companies to start taking a stance on this. But let's take the case of Facebook. Like when you're using Facebook's platform, you are their product, right? You're generating a lot of user data, then they can then market towards you with advertising. So for you to use Facebook, you basically need to, at least in this current world, just accept that that's what's happening and that's the price of using their platform. But do they really need to see your raw data? So what we've thought of, for further down the road here is, with Hypernet, one of the implications is that, hey, maybe we can leave data where it is. Maybe we can still get all the same analytics we'd want to get out of that data that Facebook was getting anyway, without ever actually needing to make the data move towards Facebook's servers. In this case, so let's take this a step further. So the smartphone that you're using is actually one of the greatest sensors on the planet. It's generating a lot of data all the time about people's interactions with certain applications, in this case, a social media platform. So within the social media platform, every interaction you do, whether how long you look at photos to maybe the conversations you're having in the car are all being kind of logged on the on a platform like that. And that is where it's kind of interesting as well. Does that data need to be moved? Can it be left there? And if so, can you provide the social media platform the same level of intelligence about the network without them actually being able to pinpoint exactly who you are, and for Facebook or whoever to say, hey, I know Ryan like watches cat videos 5 times a day, you know, on the Facebook.
Mm-hmm.
And so with that, with Hypernet, what you can possibly do on the network is say, hey, I can get, with our toolboxes, you can get your analytics from the data, let that data sit with the user. The social media platform still gets the intelligence, but then you let that raw data evaporate away, and you never see it again. Almost like evaporative analytics. I don't know. That's a term that we've been throwing around ourselves. Yeah. And so that's kind of one of the visions of the platform is can reinvent this notion of data privacy, but also has further implications for, let's say I move into a world in the next few years, you know, the Internet of Things are coming online, the Internet of Everything, where all these devices are more connected and generating a lot of data in the real world. We're going to run into issues where you can't pipe all that data back to the cloud to get some intelligence from it to then tell these devices to do the next thing. So what some of the larger companies are doing is saying, okay, we're going to move to this thing of something called edge computing, where we're going to build smaller and smaller data centers closer and closer to where the data is being generated. That has a bunch of issues with them as well. But, you know, that's the only option at this current framework. But what we're saying is like, well, with the Internet of Things, you're generating all this data. It's the same kind of thing as with a social media platform and app from a user perspective, except in this case, now you're generating a lot of video data, cameras, microphones, sensors in terms of pressure. You know, you're generating all this data and you want to learn from it. We can leave that data where it is to get your analytics across the network and near to real time, you know, update your models that are there so you can make your decisions. And then later, if you wanted to, you can push that data back to the cloud for archiving or storage. But to actually leverage that amount of data that's produced in the real world, we can use Hypernet to crunch it.
Interesting. And I guess that in terms of costs, it's much more beneficial for those enterprises.
Well, you start to look at, you know, like what does it cost to run a data center? You know, at the end of the day, right, you have the energy, of course, that's what's converted to information, right? Mm-hmm. You have the cooling infrastructure. You have the cooling power that's also run the cooling pumps or whatever you're doing. You have the property, you have the maintenance, you have the personnel, and then you have the hardware as well. And so when you kind of add up this whole stack of costs, what you start to see is hardware costs in a data center like accounts for a very large fraction. In fact, some of the stuff we've been looking at, it's up to maybe 50% of the operating cost of a data center is tied up in this amortized hardware over time. So if you move to this environment, especially in the early days, this is one of the main value propositions of computers that are on the network, you know, of like people like you and me who own our computers to function in everyday society and want them just to make us extra money while we sleep. You know, we bought these things for other uses. So we don't necessarily need to recoup all that hardware cost because we're getting value out of it as it is. Maybe it's my gaming desktop that I'm playing games on for like 8 hours a day. And then I then sits there the rest of the time. You know, so perhaps you can make extra passive income, and by virtue of this sharing economy, you can actually drive down the cost significantly of the compute as a whole.
Interesting. Yeah. Yeah, that part is very interesting, and then I guess so then people can use or can give the space on the computers that is not being used, so that these enterprises can use it, and then they get paid on the with Hyper token.
Yeah. So the token model itself has actually the main purpose of the token model is not quite the payment channel. We can totally accept payment in Hyper token, but mm-hmm. the real use of the token itself is the staking mechanism, because you know we have a network now of a public resource, if you will, where you don't know like people's reputation, you don't know their intentions, and there needs to be a way to govern the network. So the ability to have the right to earn revenues from the network, you need to stake hypertoken to your devices. That gives you the right to enter the network. Now that you're there, you can make as much money or as little money as you want, because you now have that right to enter the network. But as an added feature of the network itself, that stake that you put on your devices, that collateral, is at risk if you fail the job or are a malicious actor. So this prevents people from just creating a bunch of ghost instances. It prevents people from lying and failing a compute job in a malicious sense, but also provides some kind of protection for the enterprise, where it's like, if my compute job fails because someone's laptop died or their network went down, I can still recoup some of that cost and relaunch the job somewhere else. So this whole staking and slashing mechanism, I guess if you want to think of it that way, is one of the main cores of running this compute environment.
Now that you touched on that, I think it's that's a question I have is from the enterprise perspective. Let's say I'm a company X and I want to run a job, and then for, let's say, 5,000 computers, and then how maybe we can discuss this in a bit more in depth. What happens if from the 5,000 computers, I don't know, 100 stop working, or 1,000, or something happens to a percentage of those nodes?
So it really depends on the job that you've launched. So let's say we take the aircraft manufacturer case where they're running computational fluid dynamics. You know, for that, if a large chunk of the network goes down, like regardless of using Hypernet or Amazon Cloud or something, you know, you're still going to run into issues of needing to restart that compute job. That's like even if you had replication in the system, if like 50% of it went down, that's a problem. But now if you start thinking about, okay, if I'm doing some machine learning or artificial intelligence training, estimation process is what we're doing here. You know, the more data I have, the better my training becomes, and the finer tuned my models are. Whether the models are correct or not is another story, whether you're training on the right thing. But, you know, this notion of having dropouts in the network and people coming back in is a key feature of Hypernet. What we've been able to do with the way we create this compute engine is, if you wanted to do parallel computing in the cloud, you would need to implement a parallel programming model. And this parallel programming model is not like a programming language. It's basically the underlying way of how you coordinate a bunch of computers to do something together. In the case in the cloud, what it's doing under the hood is, let's say you, me, and Todd and Daniel are each running a process individually. We create a number, you know, from that. We then need to aggregate all of our data together and then rebroadcast it to everyone else. And that's how things are done in the cloud. They use a gathering and a scattering of data to do these global parallel data reductions, is what they're called. So for into all of our numbers to be added together, then the final answer to be sent back to us, they use these gather and scatter operations, where someone's a master node and will gather everyone's data and then rescatter it to everyone, so they have the next answer for the compute task. The moment you move from an environment in the cloud where you know all the devices, you know what their hardware is, you've synced up all the hardware, like they're all marching in step, and you know that they're not going to fail very often. This works very well, this gathering and scattering. The moment you come down to this world of distributed computers across the wider internet, the game has totally changed. You don't know the network topology from the beginning. You don't know where your data is actually flowing. You don't know the reliability of the network. Parts of the network might be slower than others. How do you synchronize everything? How do you handle failures where like a computer may die? And so what we've developed within our parallel programming model is these things are encapsulated there. We've thrown away the notion of a gather and a scatter. What we use under the hood is a notion of consensus. In this case, it's distributed average consensus, where as people enter the network and leave, you're injecting the streaming data into the network and it propagates through the network. And so if you die in the middle of your compute task, and we're doing one of these estimation processes, you're going to impact the solution because you're gone, but then you can come back and inject your data again. So these kind of asynchronous data streams is what we can facilitate with our programming model, which is very fault tolerant to dropouts in the network.
Yeah, exactly. Yeah, that's very interesting. So then in the network, where the actors would be, on the one hand, the device or the node owners. On the other side, the other side of the marketplace, the companies or institutions in general that would need that computational power. In the network, is there any type of arbitration in case that there's any problem between the two parts? Maybe we can talk a bit about the governance.
Yeah, so let's say we're in the middle of a compute task, and I want to now challenge my sellers on the network. I'm the buyer. I want to challenge the sellers if they have done the compute correctly or not. There's a few different ways you can do this. The most straightforward one is, well, as the buyer, I say I want 3 times replication in the network. And so now at certain steps in the compute, at certain checkpoints, the 3 parties that are there will check each other, and if someone fails, that's logged in the blockchain, their stake is gone and they're booted from the job, but the criticism of that is, well, now you have to have 3 times as many people on the network. There's also ways of doing verified compute. In general, this is very expensive computationally. It's very difficult to do, but there's certain things you can actually enforce in the network that are quite efficient. And these are methods of interrogation. So me as the buyer will say, Ryan, you've done this operation. So they did that compute job correctly, that small operation, and is quite efficient. You don't want to be doing that all the time, but that's a way of challenging compute, and that's the settlement of that challenge and response is handled by the blockchain itself.
I see. Yeah, cool. Maybe we can jump now to the go-to-market. Now that we were talking about like different actors in the network, what is your go-to-market strategy? What will be the first use cases or target groups that you think might be the first ones to tackle, or to go for?
Yeah, so it's interesting because what we're creating here is a marketplace to buy and sell compute power. We have to build up people on the seller side as well as on the buyer side of things. There's a few strategies in place to do both, because you need both for the marketplace to be healthy.
Yeah, a bit like a chicken and egg problem. Yeah.
Exactly, the chicken and egg problem. And so there's to bootstrap the seller side of the network, we have instantiated this ability to, we call it a capacity availability mining pool, I guess, if you will, where we've set aside a fraction of the tokens of the network to be part of this pool, where in the early days, maybe there's not enough compute jobs flowing through the network. To be able to bootstrap people on the seller side, what we do is we say, okay, well, from this pool, we're actually going to pay you in HyperToken for making your capacity available. So you sitting there saying, hey, I'm available for the compute job, look at me, I'm here, you actually earns you the right to earn from this mining pool. Of course, to enter into this waiting room, this lobby, you do need to still have stake on your devices to enter. And if you are a bad actor within that lobby, that stake is also lost and you're booted from that pool. So that's kind of to bootstrap the sellers. And also there's interesting things you can do where people have been approaching us for, like, they have like basically a basement data center that they want to use their spare compute cycles on, to actually server providers as well that are saying, hey, we'd love to run the Hypernet app on here so we can monetize our and expand our marketplace for our servers. So it's very interesting that the wide variety of sellers that can actually sit on the network in the early days. On the buyer side of things, we've been thinking long and hard about you know, we don't want to target a very specific, very like extremely specific use case, because that may require us to create a very specialized piece of technology that then is only works for that specific vertical. So we've been talking to quite a number of different industries to find the common ground of what exactly can be utilized on the network, and what's the very first good first step for us to develop our customer base on the enterprise side, while also being respectful of our engineering time to get a product that fits a chunk of these verticals instead of just one. So within those talks with enterprises, what's very fascinating is to be able to provide any amount of discount across cloud starts to become more and more interesting to them, especially if they use a lot of compute power for these data analytics tasks. So like to have the potential of just having a 20% reduction off of their cloud costs is very palpable for them. So that's kind of what we're looking at for going to market in the early days.
Cool. Yeah, very interesting. Now that we were talking about going to market, and then maybe we can discuss competition. Not that much, but just some of the questions that I got before when I was doing the research is people ask me what's the difference or in the approach that Hypernet takes from others like Golem or Son.
Yeah, of course. So really, it's interesting because we're all targeting very different use cases. While the main vision of having a global network of computers kind of remains the same. With Golem, they've been doing a great job getting up to this the rendering tasks there. Rendering, though, is one of those process types that's considered embarrassingly parallel, kind of like SETI at home, where you take your job, you slice it up into a bunch of pieces, send it out, but each piece doesn't need to talk to anyone else. You know, you just assemble the final thing like a puzzle. The moment you want to do something more complicated, like your machine learning across distributed data, or your computer simulations, or your financial modeling, you end up with the need to have a parallel programming model that's robust for this environment, and they don't have that yet. And so they're focusing on these embarrassingly parallel tasks. Also, they're providing the execution environment, which we are too, but within their execution environment, it's up to the developer to figure out how to use it. We're providing this compute engine underneath it to let you actually leverage the full capacity of the network. Sonam's focusing on these hub and spoke server type models, which is basically cloud technology there. But you run into scalability issues as you try to get bigger and bigger with the types of problems you're solving. So that's kind of where some of the differences lie. Basically, it all comes down to, one, we're providing a computational environment, which everyone else is doing, but we're also providing the meat underneath it to let developers, enterprises, and everything to leverage the network to its fullest capability, and actually making that easy for people to do. Because what good is technology if there's no way for to get users on the network and to make things easy to integrate into existing systems? So that is what we're focusing on.
Speaking of that, how to make the network easy, you said that for developers, would they have to learn something new? Can they just, if they're already been developing it on C++ or Java?
Yeah, so what's great is what we're providing here is an API to allow you to leverage the parallel programming model. The source code is all written in C++, and there's a Python bindings for now. So if you're used to coding in those projects, those languages, you can include our libraries into your code base. There'll be wrappings for other languages as we go forward, because we don't want to reinvent the wheel. We don't want to have someone learn a new programming language to use our network. Now, let's say I did want to do a parallel compute job using Hypernet, and I'm familiar with using MapReduce or MPI, the message passing interface, to execute my parallel programming model, my parallel task. You would implement Hypernet's API, the DAC API, the same way you would those. So you interface with it the same way people know how to interface with the parallel programming models of the past. which will ease into adoption as well. But also we're baking into these toolboxes the ability to do can-bake functions, where if I want to do some least squares regression on my data, or if I want to do a singular value decomposition, you know, I call that function within the API and it handles it all in the back end for me. So we want to make this very user-friendly. So eventually the goal is to have any like you know, you write your 4 lines of code to do your thing that you want to get done, and we'll handle on the back end with the API and the toolboxes.
Cool. Yeah, that's interesting. And now let's discuss the roadmap. Let's go through the roadmap for this year, and then let's discuss more the big picture. Where do you see the big long-term vision? So for this year.
Okay. Go ahead. Yeah. So this year, so we're marching towards like our first functioning like MVP, I should say, in August, where we can actually launch the network. That's the plan. So as we move towards that, we have several milestones we've been hitting. We actually have a full working tech stack and demo applications on our testnet, which are pretty exciting. Maybe another time we can show you the demo.
Yeah.
Cool. So that's been done for like a month now. So we've been now fleshing that out to move towards and following that technical timeline we've outlined on our website towards launching the network in August. That's the plan. So now as we move forward towards the end of the year, we want to start fleshing out these toolboxes like we were discussing earlier, so people can start to easily integrate into the network. And then going forward is really like the big picture. We haven't unleashed our longer roadmap yet publicly. It's pretty exciting though, because, you know, depending on the trajectory as we start onboarding enterprise users onto the network, will allow us to start fleshing out the technology itself and to grow the network as a whole. So to initially seed the network in, actually very soon we'll be launching a web application to allow people to start pledging devices to the network and interact with us on another level on our website. So that's going to be pretty exciting on our front leading up to the network launch. And going forward in the future, our vision is really like, you know, we envision this compute engine and this marketplace really fueling the next level of innovation that's coming out. You look into history as we have paradigm shifts in how we're doing computing and how things are done. This access to computing power and this access to vast amounts of it, every time we have this radical shift from the mainframes to multi-core machines to personal computers to the cloud, it's accompanied by a very large boost in innovation, because now we have access to tools that we didn't have access to before. So the next logical step is going from the cloud into the sea of computing that we've unwittingly seeded across our globe. And so to be able to utilize that is the dream, and to power the next coming wave of innovation. So whether it's IoT, whether it's things we can't even think of yet, you know, this is where we want to see Hypernet being proliferated in. And that all begins with our initial push into the enterprise world and getting people using Hypernet.
Cool, that's very interesting, and that ties up very well with the whole decentralization idea of the blockchain. Of course.
Mm-hmm. In fact, like when we first had this, we started down this journey of distributed computing, like we ran into a problem of how do you schedule a job on a completely decentralized network? How do you even make the network robust? So if this is powering the like smart cities and IoT, you know, we can't have it going down from like very centralized attack vectors. And so the blockchain technology solved those problems for us in the computing world, which is how we ended up with the full product that we have today. We started off with, hey, you know, there's a need of computing. There's all these computers out there. Let's find a way to connect them. And then out of that need evolved the realization that like the blockchain technology facilitates a large portion of that technical stack and also lets us execute that vision. So we're very excited to be alive at this time. We can be part of this decentralization of a lot of our industries.
Yeah, and I think also personally, I think that you also location-wise, you're just in a very good place, being in California with and on close to the valley, with so many companies that are in the tech space that are encountering the problem of not having enough of running out of computing capacity, basically.
What's actually very fascinating is well, also just down the road from our house here is the Steve Jobs Apple Garage, which is pretty funny. But also, like, here we're talking to, like, this comes up a lot, especially this one company where they spun up every single GPU instance in an Amazon data center to do one of their machine learning tasks, and that's just one company, you know. So that kind of shows you how even though we do have a lot of capacity in the cloud, it's still not enough, especially for as we move forward to this next era of technology.
Yeah, exactly. And I mean, I think it's you're very well located more on a geographic point of view, but also in the being in the blockchain space, also for these companies that are running, like you said, like out of computing capacity, and also all these new companies that are getting tech companies that are getting funded through the blockchain with all these ICOs that will need also, of course, more computational capacity.
What actually kind of great you bring that up is the way we're doing the computing again. This computing engine based on consensus allows these decentralized applications to truly utilize the decentralized network of their users to do the compute that they would require for their applications without needing to have a centralized server to handle that portion of it. So that's kind of one of the supplement things we can bring to the blockchain ecosystem as well.
Yeah, that's very interesting. I think, speaking of which, we just we're now almost finishing. Are you guys planning to do an initial token offering in this year, next year?
Yeah, so no announcements have been made around token sales or offerings at this point.
Okay.
But feel free to come to our website, hypernetwork.io, sign up for our mailing list and join our Telegram. Our community is growing, and we'd love to see you there and ask us all the questions your heart desires.
Perfect. Thank you very much. The same for all the guys that are listening. Please, if you have any questions, just go to directly to Hypernet's Telegram. Contact them. Check their website. They have a very interesting white paper as well. And sign up for the newsletter, as Ivan mentioned, so you can know everything as on time when there are new things on the roadmap being released. I guess you guys will be sharing that with the community.
100%. That's if it's stay up to date with all the official announcements, sign up to the mailing list. We got it.
Perfect. Yeah, I think from my side, I think we covered a lot of the technology, but also about the bigger picture on decentralization and how to use this unused space, computational capacity by leveraging the blockchain technology. I don't know if there's anything else that you would like to discuss, Ivan, that we didn't discuss already.
I think we covered quite a lot in this interview, Ryan. Yeah. Thank you again for that. Yeah, just thanks again for having me here, and I look forward to perhaps doing a follow-up sometime soon.
Yeah, sure. Yeah, I'd love to do it. Like you said, maybe we can go sometime soon through the MVP that you said, so then we can see the demo as soon as you have it.
That'd be great. Let's get something on the books.
Awesome. Okay, thank you very much, and thank you guys also for listening to this interview with Ivan Ravlich. Ravlich is the right pronunciation?
Yeah, that's correct.
Yeah, with Ivan Ravlich from founder and CEO of Hypernet. So thank you, Ivan, and thank you guys. Cheers.
Thank you all.
Bye-bye.